Hello, class. Welcome to lesson number 3. Today we are going to talk about a couple questions that I saw on the comments in that discussion that I posted on ManageBack. So I saw these 2 questions or some version of these, and I thought they were great questions. So today we're going to talk about them and see how they kind of relate to everything else we've been talking about. So the first question was, how do we find the volume of a shape? This is a great question, right? We talked a little bit about volumes in our very first lesson and in our last lesson, I believe. And then the second question was about rational and irrational numbers in math. So it asked, why do we need both rational and irrational numbers in math? Can't we just use decimals or fractions? So this is also a really good question. I'm going to try and answer both these and kind of tie them together today in our lesson, and you will do some investigating yourself to help us answer both of these questions. So let's start with the volume question. How do we find the volume of a shape, right? How do we find volumes? We saw this in our first lesson. We had some formulas for it. But first of all, let's define volume. What is volume? Take a moment. Turn to someone next to you. Explain to them what volume is. So, volume is the measure of how much space an object takes up in 3 dimensions, right? So that would be like the X, Y, and Z dimension. Objects we typically think of as existing in 3 dimensions, like your desk or your pencil are all 3-dimensional, right? They each take up a certain amount of space. The volume is how much space they take up. When we want to calculate this for a given shape, right? Like we have this nice cube, 3-dimensional cube, right? So it has a length, a width, and a height. Those are its 3 dimensions. How do we do that? So let's say that each small square has side lengths of 1. So these are the small squares, right? We're saying that each of these side lengths is 1. So that is the information you're given. The questions then are, what is the length of one side of the big cube? That's your first question. This is the big cube, right? This would be one face of the big cube. What is the area of one side of the big cube? So this is a side, right? What's the area of this? And then what is the volume of the big cube? So, real quick, take a minute, pause the video, answer these 3 questions. You know that the small square has a side length of 1. What is the length of one of the big sides? What is the area of one side? And then what is the volume of the big cube? So, the length of one side of the big cube, right? We have the squares are each have a length of 1. So we have 1 length, and then we have 2 lengths, 3 lengths, 4, right? So the length of one side is 4 because we have 4 of the squares. Each of them are 1, right? 1 plus 1 plus 1 plus 1 is 4. When we talk about the area, right, now we have this side of 4 and another side of 4, right? So there are 4 sets of 4, 4, 4, 4, 4, right? So the area will be 4 times 4, which is 16, or 4 squared, right? We're learning about indices. So the area we can say is 4 squared, 4 times 4. When we start to think about the volume now, we can think about it in 3 dimensions. So the first one, the length was 1 dimension, right? The area was 2-dimensional, length and width, and now the volume is 3-dimensional, length, width, and depth, I guess in this case we're gonna talk about it like that. So we have each of these squares is 1, each of its sides is 1, so we have this area of 4 times 4, and then it goes back 4 as well, right? So 4 times 4 times 4. It's going backwards. We have 4 sets of 4, 4 times in a row. So it would be 4 times 4 times 4, or 4 to the 3rd power, 4 cubed, right? We can see another graphic up here. Depending on how many squares you have, you will get a different base number, right? If you have 2 squares on your base, it will be 2 to the 3rd power. If you have 3 squares on your face, it's 3 to the 3rd power, right? Keeps going up. So this, for a cube, it's pretty straightforward, right? We take the length of one side times the length of the other side multiplied by the length of the third side, right? That tells us how much space we have. But the volume formula depends on the shape of the object. Not everything is a cube, right? And this is all stuff we're going to focus on more later on. There's a chapter we're going to talk about volumes and 3-dimensional shapes. But I want to give you an idea, right? I've got some circles over here. So like we just said, for cubes and rectangular prisms, the area is equal to the length times the width times the height, or sometimes we might say the depth, right? The side length times the next side length. So length, width, height, all times each other. That will give you the area. What about circles or spherical objects, right? And we see here, right, if we go back for a second, sorry, the first dimension, the second dimension, and the third dimension are all related to each other, right? Like this is 1 dimension, 4. It's multiplied by the second dimension, 4 times 4. That gives you an area, and then the area is multiplied by the third dimension. So they're all related to each other. So when we think about circles and spherical objects, something similar is going to happen, right? But let's look at a circle first, right? Circles have a point in the middle. We could call that like the origin, right? And then they have a diameter, which is the length from one side to the next, passing through the origin. They have a radius, which is half of the diameter, right? With the length from one side to the origin. And then the circumference, which is like the perimeter of the circle, the outside, the boundary, right? Like it's a special name. The circumference is what it's called. So these are our values we get to work with, right? When we are trying to figure out the area and then the volume, right? So area would be for a circle, volume would be for a sphere. So this is a sphere, right? A sphere, if you imagined turning the circle in 3 dimensions around itself, it would create a sphere, right? So the area of this is going to be related to the volume of this. Today, your assignment is to figure out how to relate some of these things together, and then eventually we will use those relations to figure out area and volume. So again, circumference, the outside, the boundary of the circle, diameter from side to side passing through that middle point, the origin, radius is half of the diameter, so from one side to the origin. So for your assignment today, you're going to look at the relationship between the circumference and the diameter of a circle. There's a special relationship between these two things, and you're going to discover it. So you're going to need some materials. Hopefully you have something to measure with, so like a ruler, a measuring tape, meter stick, and something flexible like string or yarn. you are going to create a method to measure the circumference and the diameter. And then you're going to use these measurements to complete the worksheet and discover the relationship. So you are going to create your own method here. So I think perhaps getting in partners or small groups will be helpful. Whatever the teacher in the class thinks will work best, that is great, but probably pairs of 2 or groups of 3. Create your own method to measure circumference and diameter. You're then going to pick 5 circular objects, right? So find some circles in the room and measure them using your method. And then you're going to answer some questions. You're going to have some discussion. You're going to discover this relationship. And then we'll be able to figure out area and volume, area of a circle and volume of a sphere, right? So you're gonna do this. You're gonna work through the worksheet. There's some instructions on there. There's some questions, and then after you've done all this, you can come back to the video. So we're gonna pause the video here, and I will talk about what you have discovered in your inquiry here. So go ahead, pause the video, look at those worksheets, develop your method, measure some circumference and diameter. Good luck.